All right, number 19. Go back and look at these. All right, y equals x. Y equals x cubed. Y equals 1 over x. And y equals sine x. These are your odd functions. So odd functions are symmetric in the first and third or the second and fourth. Now, did we get most of these? Sine, everybody, if you look, sine does this and then does that. So if you look, they're symmetric. Okay? So any questions about the four that are odd?
So does that mean no matter, like if it's that function, if that's the parent function, then it would always be?
No.
Okay.
So if it was shifted left or right or up or down, necessarily no.
What about the greatest integer?
Yeah, we put that too.
Yeah, I also put that.
But it's not symmetrical.
No, it's not symmetrical. Exactly. Yeah, if you look at the greatest integer, you've got that,
Oh, the dot.
and then you've got that, and then you have this. So, yeah, this, if you look at it, it's not. It looks like it would be. The greatest integer is one of the most confusing ones because it does almost look like y equals x, and you would think it would be, but it's got some little differences about it. Yeah, good question. 20, the functions that are increasing on their entire domain. So, what questions did you have when you read that? Increasing on their entire domain. They just keep going up. Yeah. So those would be y equals x. Does that make sense? Y equals x cubed. I don't know if y'all got this one. Y equals square root of x on its domain. It didn't say the domain had to be negative to positive. On its domain, y equals e to the x. Y equals natural log of x. And y equals 1 over 1 plus e to the negative x.
So absolute value is not one?
No, because it's not in. It decreases the first half, and then increases.
Yeah, I had the greatest integer again. Yeah.
So you had absolute value, and you had greatest integer. But it's not increasing because part of the greatest integer is that it stays the same. It's constant on those little sections. Yeah, good question though. Very good. Number 21, the functions that are decreasing on the interval negative infinity to 0. Now, when we're talking about increasing and decreasing, am I concerned with the x values or the y values for increasing and decreasing?
X.
It is x. Max and min is y. But you guys, you may want to make a note that increasing and decreasing are all to do with the x values. So when it is giving you this interval of negative infinity to 0, that is this section right here. So it says, let's see, number 21, the three functions that are decreasing in this section, going down in this section. So that would be y equals x squared, y equals 1 over x, and y equals absolute value of x. Right here going down, right here going down, and right here going down. From negative infinity to 0, it's decreasing, going down. Okay? Now, 22. The three functions with three functions with infinitely many local extrema. Throw some out there for me.
I put cosine.
Sine and cosine. Infinitely many. Infinitely many means that it has these constant highs or lows or both. Now, what's the last one? I don't know if anybody got it.
1 over 1
No, because that one stays going out. It doesn't have a high.
Oh, okay.
Is it reciprocal?
No.
How about, natural law?
Now, guys, when I'm talking about, here's natural log. Does that have infinitely many highs and
No.
lows?
I don't know what
What's it called?
Cubing.
Wait, logistic.
The logistic
That's what.
looks like this. Infinitely many highs or lows. I mean, not a high,
X.
but highs and lows.
Greatest integer?
Greatest integer.
Oh. Hey, I think
Because, and the other thing is it says local extrema. So the greatest integer is another one of those because if you look right here, this point is not included. This point is not included, so that's a max for this right here.
Okay.
I know, that greatest integer is a tricky one. 23, the three functions with no zeros. Now, I don't know if you know what no zeros mean. Like, does it mean no zeros in the domain? What does no zeros mean?
It doesn't end.
Does not touch the x-axis. So you might want to circle that. Zeros or roots, typically, that's what we refer to as touching or crossing the x-axis. So there's three of them that do not do that. They are 1 over x, reciprocal function, exponential function, and logistic function.
Anything else?
These do not touch the x-axis.
25. 24. 25.
All right, number 24, the three functions with a range, all real numbers. That means the graph is going all the way from the bottom to the top. Y equals x, x cubed, and look, all the way from the bottom to the top. If I start scanning, negative infinity to positive infinity. Same goes for the cubing function, negative infinity to positive infinity. Same goes for the logistic. It's continuing to go up, it goes up slowly, but it's negative to positive. All real numbers. All right, 25. The functions that do not, I didn't give y'all that one. I didn't give you 25 or 26. 27. All right, there's your 27. Sine x, let's see, it says the four functions whose graph look the same when turned upside down and then flipped. So let's look at the y equals x cubed. You're going to draw it like this. You're going to flip it upside down, and then you're going to rotate it about the x-axis. So these are the ones that look the same, flipped upside down, and then rotated about the y.
I just can't picture that. Like if I'm looking at a graph, I'm not gonna be able to do that on.
And I don't think these are going to come up again. It's not that critical. But, so y equals x. Here's y equals x. I'm going to flip it upside down, and then when I flip it across the y, it goes back to the original. 1 over x, here and here. Here it is, flipped. And then when I rotate it about the y, it goes back to the original. All right, there's your 28. The two functions whose graphs are identical except for a horizontal shift, y equals sine and cosine. And looking at 69, it says 69a says 7 of the 12 basic functions have the property that f of 0 equals 0, which 5 do not. So when we're talking about f of 0 equals 0, that means x is 0 and y is 0. So the 5 that do not have that are these 5. So at cosine, at x equals 0, y equals 1. There's a vertical asymptote here at x equals 0, y equals 0, vertical and horizontal actually. At natural log, it's undefined. It's a vertical asymptote. E to the x at x equals 0, y equals 1. And on this one, all right, there's your 1 minute.
That's more than apples dropping.
They're gonna be $3,000 each. Yeah, and apparently there's more colors and more batteries.
Weird right now.
They just brought
He looks like
just
Coach
announced it.
Star.
But it's the only like thing
Oh,
about
he's
it.
got-
Coach Corey. Corey Hastings.
That teacher. We never had him. I was friends with him.
Basically, his class was just sitting there and doing anything else on your computer because he gave you so much projects. And then doing the project at like the very last second.
All right, 10,
Yeah.
9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so kind of turn around and get your desks in order, and we're going to work 25 and 26 and then a couple of piecewise functions together. All right. All right, look at 25 for me. 25 is asking about end behavior, so I need to define that for you. It says the 4 functions that do not have this end behavior, and I've written it up here. Now, what I want you to write down in your notes is end behavior basically is what is happening at the 2 ends of the graph, and we're looking at the y portion of that. What is the y doing? So this is what they've written in 25. LIM stands for limit, and you'll see this a lot in calculus. The limit as x approaches positive infinity, that's telling you where to look. So this is kind of like your GPS or your road map. It's telling you where to look. Then f of x always stands for y. So you read this as the limit as x approaches positive infinity, and it would help if I could spell infinity. Let me just make the little symbol. Okay? The y is approaching what? And in this case, they're telling us that they want the y to approach positive infinity. So x is approaching positive infinity, which means I'm looking to the right of the graph. That's where all my x numbers are going to positive infinity. Does that make sense? Shake your head or nod. So all this is doing is telling me which side of the graph. Now, they're saying that the end behavior is when this is happening, the y is going to positive. So you see my green arrow.
Even if it's positive infinity for y can also, it's just anything up. So what if it's going the other way and then x is negative? Like
It would have to say as x is going to negative infinity.
okay.
This is telling you specifically, and we will look at those that are going to negative. But this is specifically this one right here. So the 4, so let's take a look. If we're doing this is y equals x. As I'm going here, this is going to positive, right? Squaring is I'm going to the right, this is going to positive infinity. You see what I'm talking about? The 4 that do not have that are sine, because it's oscillating. It goes positive, then it goes negative, then it goes positive, then it goes negative. Cosine, it does the same thing. The reason why this isn't 1 is because as this is going to positive, this is approaching a horizontal asymptote. So this is not 1. The reciprocal function is not 1 because my y is approaching this horizontal asymptote. Y equals 0. It's not approaching positive infinity. And the same thing for this one. It's going up, but it's not going to infinity. It's approaching a horizontal asymptote at y equals, was that 1?
Mm-hmm.
Okay, at y equals 1. So that's why these do not, even though this is supposedly going up, it's not going up to infinity. Okay? Any questions on that one?
So the graph right there in the middle, the one that's going down to the asymptote at 0, does that stop?
No, it is bounded below.
Okay. Because it can't go negative.
If I just had this part, now it's really not bounded below. But if I'm looking at just this section of it. Okay. All right, let's look at, we don't want to look at that just yet. Let's look at number 26. Now this time, they're giving you a different limit. The limit, as x is going to negative infinity, they want the end behavior, the y, to go to negative infinity. And it says 3 functions have this end behavior. So look at yours. Now, this time on the x, I'm going to the right or the left? Left. And my y is going up or down? Okay. Find me the 3 that have that.
Would it be exponential?
No, because exponential does not go down. Exponential hits this, does not go to negative infinity. Exponential hits this horizontal asymptote. It's going down, but don't confuse going down with going to negative infinity on the y, because this is not. Okay?
Natural log will.
Natural log, but not as we're going, there's no x to negative infinity on natural log. So that, no, but I'm glad we're clearing these up.
Could it be absolute value if it was negative?
No, it'd be absolute value if this was positive. Because absolute value on the negative side is going up to positive infinity.
What is the absolute value itself? Like it was
Oh, then yes,
like
then it would,
yes.
yes.
So y equals x.
Y equals x is one of them.
And then 1 over x.
1 over x. No, hold on, wait just a second. No, 1 over x, because this is, no, because as you're going, not 1 over x, let me explain why. For 1 over x, as you're going to the going to the negative x, negative infinity, it's not going to negative infinity, it's going to this horizontal asymptote. So that's not one of them.
X cubed.
cubing. Mm-hmm. There's one more. What? Greatest integer.
I hate that one.
It gets all the hate.
No, well deserved.
But I'm glad we talked about why these others are not, so that you understand. Okay, so we're going to do now a couple of piecewise functions together. You'll like these. 45. They want us to sketch these piecewise functions. So I'm going to do a couple of them with you. Okay, so go ahead, and if you want to take out another sheet of paper or do it on the back, I don't care. But we're going to draw a grid, and it is a sketch, so it doesn't have to be absolutely perfect. But there are some key things that, as we go over it, you'll see that you have to do. All right, so draw yourself a grid. Now, the first thing that we did these the other day, so I want to dot in this function, and you should know these because you're going to have a quiz on them tomorrow. So y equals x is the graph, and I want you to dot it in, the graph of a line with slope 1 going through 0, 0. So if you draw it above or below, you're wrong. Now, I'm not going to check to see that that's 1 and that's 1 and that's 2 and that's 2 and that's 3 and that's 3. It should go about halfway, okay, and it should pass through 0. Now, which part of this graph do I want? Which piece, that's why these are called piecewise functions, which piece of this graph do I want? Well, I see this 0, so I'm going to put my pencil at 0. And which side of the graph do I want? The up and to the right or the down and to the left? Down and to the left, because that's where my x's are less than 0. So I'm going to make this a solid line, and then I'm going to go back in and I'm going to erase that. Now, this is a picture of a what? Parabola, upward facing you. So I'm going to dot it in, and again, with this being a sketch, I'm not going to worry that the 1 is at 1 and the 2 is at 4, but it does have to hit 0. Okay? Now, which part of this do I want? I'm going to the 0. Do I want up and to the right or up and to the left? Up and to the right. By the way, guys, if I drew this right here, it would fail the vertical line test. It would not be a function. And it says these are piecewise functions. So the part that I'm going to make solid is that, and I'm going to erase this. So that is a piecewise function. We're taking pieces of functions and combining them. So I want y'all to try 46 right now. and you'll eventually get where you can graph the piece that you see. This is a cubic. Make sure that it has that point of inflection at 0. Okay, the part that I want is where x's are less than 0 or they're negative. So that's the part that I want there. Okay, now on this one, if I drew an exponential, this is where I'm going to get a little bit picky even though it's a sketch. An exponential goes not through 0 but through 1, correct? So these don't touch, and I'm not saying that they have to. The part that I want on this one is that, but there's one very important thing that I better do, and I want y'all to tell me what it is.
Do a line between.
No, now these can be completely separate, that's okay. A dot at 0, not a dot.
An open.
Open circle, because does it include? No, and in fact, if you had a dot here, that would fail the vertical line test at that point.
And these have to pass the vertical line test.
Yes, because they are piecewise functions. So it's those little attention to, yes. And it's those little attention to details that you'll have your professor, and I was even sitting in grad school and he was just and I couldn't figure out exactly why he was coming up with what he was coming up with, and then I went back and I reread the question and it said something about integers. And so that little detail of that they wanted an integer made all the difference in my answer. So you have to pay very close attention. These are just not piecewise graphs. They are functions. All right, so these are the last two we're going to do. I want you to do 47 and 48. have those about done. Okay, 47. 47 was absolute value of x. And sine x. So you'll get where you're just starting to draw these by looking at the function. I know that that's a v. I want the part where x's are negative. Okay. The sine x for the x's are positive. Something that looks like that. Okay. Anybody have any questions about drawing 47? All right, let's look at 48. 1 over x. And square root of x. So I know the 1 over x is right here and right here. I want the negative part, the x is less than, so I'm going to draw it like this. And then the square root, and there is a dot there. And you can put arrows on them or leave them off, it's okay, either way. All right, any questions on the piecewise? Okay then.